An engineer is interested in testing the bias in a pH meter. Data are collected on the meter by measuring the pH of a natural substance, which is pH equal to 7.00. A sample of size 10 is taken with result given by 7.07, 7.00, 7.10, 6.97, 7.00, 7.03, 7.01, 7.01, 6.98 and 7.08. Calculate the mean and standard deviation of the sample taken. So we use the formula mean. First, mean is the average of the data values. So first, add all of the readings together, then divide the sum of the number of readings, which is 10. 0.07 plus 7 plus 7.1 plus 6.97 plus 7 plus 7.03 plus 7.01 plus 7.01 plus 6.98 and plus 7.08, which is equal to 70.25. So 70.25 divided by 10, the answer is 7.025. So the average reading is 7.025, which is also the mean. Then calculate the standard deviation. First, find the difference between each reading and the mean, then square each difference. For example, 0.07 minus 7.025 squared is equal to 0.002025. Repeat this process for all of the readings. Then add all of the squared difference and divide the sum by n minus 1, which is equal to 9. So 0.01745 divided by 9 is equal to 0.00194. Then 0.00194 square root is equal to 0.044.
3 cards are drawn in succession without replacement from an ordinary deck of 52 playing cards. Find the probability that the event A1 union A2 union A3 occurs, where A1 is the event that the first card is a red edge, A2 is the event that the second card is a 10 or H hijack, and A3 is the event that the card is greater than 3 but less than 7. The solution is A1, we got red ace. Red ace contain 1 ace of heart and 1 ace of diamond. A2, 10 or jack. There we got 4 10 and 4 jack. And A3 is greater than 3 but less than 7. We got 4 4, 4 5 and 4 6. The probability for A1 is 2 over 52 and we can get 1 over 26. P, A2, probability for A2 we can get 8 over 51. And the probability of A3 is 12 over 51, and then we can get 6 over 25. The total probability is A1 union A2 union A3, and we can get the answer by multiply the probability of A1 times probability of A2 times probability of A3, and we can get 1 over 26 times 8 over 51 times 6 over 25, and the last answer is 8 over 5,525.
So I will continue with question 3. This problem involves selecting 2 microcomputers randomly from a shipment of 8, where 3 are defective and 5 are not. So this is the binomial distribution. First, we identify the key of parameter for the binomial distribution. First, the total number of trial, or n, is 2 because we are selecting 2 microcomputers. Next, the probability of success P or selecting a defective microcomputer is 3 over 8, since 3 out of the 8 microcomputers are defective. Then we calculate the probability for each possible outcome from 0 until 2. Then to calculate the microcomputer selected, we need to use the formula NCX times PX times Q n minus X. When X equal to 0, the probability that we got is 0.391. This happens when both selected microcomputers are non-defective. Next, when X equal to 1, the probability is 0.469. This occurs when one selected microcomputer is defective and the other is not. Lastly, when X equal to 2, the probability that we got is 0.141. This happens when both selected microcomputers are defective.
Question 4. The probability that a patient recovers from a rare blood disease is 0.4. If 15 people are known to have contracted this disease, what is the probability that from 3 to 8 people survive? Okay, so from this question, we have known that P is 0.4, N is 15, and the X is greater and same than 3, but less and same than 8. So by this information, we can make the equation of Px greater than 3 minus Px greater than 9. So to get the probabilities, we need to refer table of cumulative binomial probabilities. And by referring this table, we can get the amount of 0.8323 minus 0.0017, which equals to 0.831, which is the probabilities from 3 to 8 people to survive the rare blood disease. Question 5. 10 is the average number of oil tankers arriving each day at a certain port city. The facilities at the port can handle at most 15 tankers per day. What is the probability that on the given day tankers have to be turned away? From this question, we know that the average is 10 and the X is 15. But for the tankers to be turned away, the X needs to be 16. So by this information, we can put into the formula, which is E to the power of negative U times U to the power of X divided by X factorial. By putting in the information into the equation, we can get the probabilities, which is 0.02170.
Hi and Assalamualaikum everyone, my name is Nurhanisa binti Zulkifli. I will continue to solve the question number 6. Tests are used to reject all components where a certain dimension is not within the specification 1.50 plus minus r. It's known that this measurement is normally distributed with mean 1.50 and standard deviation 0.2. Determine the value of r such that the specification covers 95% of the measurement. This question means a 95 coverage of normal distribution corresponds to a range centered around the mean such that 2.5% on the data lies below the lower bound and 2.5% lies above the upper bound. Thus, 95% of data lies within plus minus standard deviation of the mean. The mean is equal to 1.50, the standard deviation is equal to 0.2, the variance is equal to 0.04. So, 2.5% is the left tail and 2.5% is the right tail. So, 95 plus 2.5 is equal to 97.5% or 0.975. Refer table Z, so it lies on the 1.96. Or we can use another solution, which is 1 minus 0.0975, so we got 0.025. Refer table Z, and 0.025 lies on the 1.96.